Hello and welcome to section 1.1. This is the first video that you will see in pre-calc. I'm actually going to skip the majority of the intros and talk about those in class, but I want to get you the basic information for the day. In section 1.1, it's a geometry review. We do Pythagorean theorem, distance formula, and the midpoint formula. And so I'm just going to talk about all three of those, give you an example, and we'll discuss more in class. So I'm going to start off with Pythagorean theorem. Pythagorean theorem basically says for every right triangle, okay, and a right triangle being a triangle that has a 90-degree angle, for every right triangle with legs A and B, and legs are the shorter two sides, and a hypotenuse of C, and this is labeled the same way it did in geometry, hypotenuse being the longest side, then we know that A squared plus B squared can equal C squared. Now please keep in mind it has to be a right triangle in order for Pythagorean theorem to work. And so we're going to give you an example on a coordinate plane, and I'm going to change my color here a second. But take a look, given a point at 2, 3, so a battleship at the point 2, 3, and I'll explain the battleship reference in class, and at another battleship of 5, 7, so at 5, 7, basically, can you find the distance from the first battleship to the second battleship? And we're going to talk about distance formula in a minute, but I want to show it to you using Pythagorean theorem. And so what we're going to do is we're going to make a right triangle. Okay. Given again, this is the point 5, 7. This is the point 2, 3. Okay, so we're going to make a right triangle. In order to get this distance, we subtract the y values. So 7 minus 3, this distance then is 4. To get the distance here, because we're going horizontally, we're going to subtract the x values. So 5 minus 2 is 3. And so you'll notice we have sides here of 3, we have a side here of 4, and so let's talk Pythagorean theorem. Now this is one of the triangles we kind of expect you know is a special right triangle, but let's show you how it works. So let's say we're given just a basic right triangle, with this side being 3 and this side being 4, and the question is, what is the length of the hypotenuse? Well, according to Pythagorean theorem, 3 squared plus 4 squared would equal C squared. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. Okay? If I square root both sides, please remember that when you square root both sides, you should have two answers. Let me actually make the correct answer here. Positive or negative 5. In this case, though, can distance ever be negative? The answer is no, so our answer is just 5. And so the distance between the first battleship to the second battleship is a distance of 5. Okay, and again, we were going to ask you to use Pythagorean theorem. We are also going to ask you to use distance formula, but I wanted to be sure that I showed you both. We're going to second look at the distance formula. So let me slide this down. We'll do our second example. Okay, the distance formula, and I'm going to write it right above because my screen's not quite big enough, but the distance formula is given in your textbook, and this is one we expected, you know, from geometry. The square root of x2 minus x1 squared plus y2 minus y1 squared, and again that whole quantity then gets square rooted. We again expect that you know that, but I'm going to show you an example, and this is a question that we like doing, talking about when it comes in terms of the quiz. Let's see if I can get my hand to right here. And so keep this in mind, we are going to ask you things about the distance formula. Now I'm going to label my 3 points. I'm going to call this A, I'm going to call this B, and I'm going to call this C, so that I get back into geometry notation. A is the point 2, 1. Okay, so I'm going to label that A. B is the point 4, 0. And C is the point 5, 7. Now, as you look at this, it does not look like a right triangle, so I don't want to even try and use Pythagorean theorem. But what I do want to do is label the other side so I can talk about the distance formula. Well, across from angle A is side A, across from angle B is side B, and across from angle C is side C. And I'm going to label them this way so that when I talk about the distance, I can just talk about a side. So I'm going to start with side A. And side A is from B to C, and the order doesn't matter. But if I look at B, and maybe I'll label the points here for you too. 4, 0, this is 5, 7, this is 2, 1. Just so that our sides are labeled. But let's take a look. From 4, 0 to 5, 7 is where we're looking to go. And so if I look at side A, let's do it the square root, okay, of 5 minus 4 squared. So I'm taking C to B. And I have to do it, it doesn't matter the order as long as you do it in the same order the other way. So I started with the 5 over here, which means I'm going to start with the 7 in the second one. So 7 minus 0 squared. Okay, this ends up getting you 5 minus 4 squared is 1. Okay, so 1 squared is 1. 7 squared is 49. So the square root of 50. And I'm actually going to leave it here. Normally we suggest you break it down, but the idea is, does it form a right triangle? And that's what I'm trying to look for. So eventually I'll use Pythagorean theorem, but right now I'm going to leave it there. Let's go to B. B is from C to A. Okay, and again, order doesn't matter, but I'm going to start with 5 and then minus 2. Okay, so 5 minus 2 squared. And I'm going to do the same order then. 7 minus 1. 7 minus 1 squared. Okay, 5 minus 2 is 3. 7 minus 1 is 6. So 3 squared is 9 plus 36. 9 and 36 makes 45. So I'm going to leave this as the square root of 45. Okay, my last side is C, which is from B and A. And again, I'm going to start with the second, the highest number first. So the square root of 4 minus 2 squared, and then 0 minus 1 squared. Okay, well 4 minus 2 is 2, and 0 minus 1 is negative 1. 2 squared is 4. Negative 1 squared is 1. So I end up getting the square root of 5. Okay, now our goal is to see if it's a right triangle. Now, according to my Pythagorean theorem, C has to be my longest side, but if I look, I didn't label that so that C is my longest side. I labeled it according to the triangle. So, as I look at this, which one is my longest side? This is the one that we're going to call our hypotenuse then. Okay, so if that's the hypotenuse, let's check it. According to Pythagorean theorem, the square root of 5 squared plus the square root of 45 squared should equal the square root of 50 squared. Because it's always the 2 legs squared is equal to the hypotenuse squared. Well, let's look. This is 5. When I square root a square, it goes away. Plus 45. Do I get 50? Then yes, this is a right triangle. Now, the reason we ask you to do it this way is because according to my picture, now my lines aren't straight either, but according to my picture, it doesn't look like it. I mean, this maybe, but I don't know, it doesn't quite look like it. What it says is my drawing's not that great, but it is in fact a right angle, which means this then should be a right angle. Okay? Again, keep in mind, we will ask you to do something like this on a quiz coming up. All right, we're going to move to the last one, which is the midpoint. So flip your page over. The last one says, what is the midpoint theorem between two sides? And I'm going to show you this picture a second. I'm going to do it on a coordinate plane. And again, I apologize for the straight lines. But take a look. I'm going to give you 1 point. Let's put it here. I'm going to call this x1, y1. And I'm going to put another point down here, which I'm going to call x2, y2. Doesn't necessarily matter the points. I'm just trying to make a point as to what the midpoint is. And basically, if I look at the distance between these two, the midpoint should occur halfway through. Okay? Now, I'm going to call this, you'll notice there's this thing extra credit, and prove that D1 is and plus D2 is equal to D3. So let me draw a picture for you. Given D1 is the distance between the first point and the midpoint, and D2 is the distance between the midpoint and the second point, we want you to prove that that's equal to the entire distance, which is D3. And if we're talking about a distance, keep in mind we'll most likely use the distance formula. Now, the question is, what is this midpoint? According to the midpoint formula, this is the point x1 plus x2 all divided by 2, and y1 plus y2 all divided by 2. And again, that is a coordinate point. And so keep in mind, again, these formulas you need to know. We will not give you these formulas. But this is how you find a midpoint. And I don't have an example to go along with it, but boy, there are tons in your book. You could also look online if you're looking for other resources or how does that work. Just go into Google and look for the midpoint. And there are a ton there, okay? And I will throw up some online resources as well to show you that. But really, that's the notes for this section. It's really nice geometry review. Please keep in mind this extra credit. Please start working on. I'm going to have this extra credit due by section 1.3. So that gives you a couple of days, and take a look. I don't want to put a date on there, but take a look as to when we're expecting that due. Thank you for watching this video. We will talk more about these 3 sections in class.